Let us look at the next problem. So let x be a subset of the set 1, 2, 3, etc. 99 and let cardinality of x be equal to 10. Then we need to show that it is possible to select two disjoint non-empty proper subsets y and z of x such that summation of y such that y belongs to y is equal to summation of z where z belongs to z. Okay, so the problem is this: you are given the set x, and x is a set which is containing 10 elements. So these 10 elements can be anything from 1 to 99. Now we need to show that there are two disjoint subsets y and z of x such that when you take the sum of elements in, so we need to find out two proper subsets y and z of x which are disjoint such that sum of the elements in y is equal to sum of the element in z. So for example, if you have a set x, so this is a set which is of cardinality 10. So you have 2, 7, 15, 19, then 23, 50, 56, 60, 66, 99. So this is a set which contains 10 elements. So if I am taking the subsets, say 19 and 50. So 19 and 50 is a subset of x. And if I take the subset z to be 2, 7 and 60, so we can see that sum of the elements in y is equal to 69 and sum of the elements in z is equal to 69, and they are disjoint, and the sets of y and z disjoint sets are. So this is what we need to prove. So x is a set such that which contains 10 elements. Then അങ്ങനെ ഒരു x ഒരു subset x എടുത്തു കഴിഞ്ഞാൽ we need to show that there are two disjoint non-empty proper subsets y and z of x such that summation of elements in y is equal to summation of elements in the set z. So we will look at the solution. And now we are given that, so since cardinality of x is equal to 10, the number of proper subsets of x will be, the total number of subsets will be equal to 2 raised to 10. Out of that you will have an empty set and the full set. So the total number of proper subsets will be 2 raised to 10 minus 2. So since cardinality of x is equal to 10, the number of proper subsets of x is, so the number of, let us take non-empty, so the number of non-empty proper subsets of x is 2 raised to 10 minus 2, so that is equal to 1022. And also for any non-empty proper subset a of x, so നമ്മൾ x എടുക്കുമ്പോൾ x എന്ന് പറയുന്ന non-empty proper subset ആണ്. So x ന്റെ അകത്ത് minimum വരാവുന്ന element 1, there can be a single element or there can be maximum 10 elements. അതായത് എക്സിന്റെ സബ്സെറ്റ്സ് എടുക്കുമ്പോൾ ഒരു എലമെന്റ് മാത്രം വരാം. അപ്പോൾ ഏറ്റവും ലീസ്റ്റ് എലമെന്റ് 1 ആണ്. അതുപോലെ you can have 10 elements in the set. Okay, so therefore when you take the sum, so you will have 1 less than or equal to summation a such that a belongs to a. So this sum will always lie between you cannot take the full the proper subsets എടുക്കുമ്പോൾ maximum minimum ഒരു എലമെന്റോ അല്ലെങ്കിൽ maximum 9 elementsോ മാത്രമേ വരുള്ളൂ. So the minimum such sum is 1 and maximum sum will be 91 plus 92 plus etc. 99. So this is the maximum sum possible for a proper subset. അതായത് നമുക്ക് maximum set നമ്മൾ 91, 92, 99 വരെ എടുക്കുകയാണെങ്കിൽ this is the maximum sum. So that is, you will have 1 less than or equal to summation a belongs to a. So this will be less than or equal to 855. So this sum is equal to 855. So that is the sum of the numbers lies inclusively between 1 and 855. And now let us use the pigeonhole principle. So let us take the boxes to be the sums. അപ്പം maximum possible sums എന്ന് പറയുന്ന 1 തുടങ്ങി 855 വരെയാണ്. അപ്പോൾ നമ്മുടെ ബോക്സസ് 1 തുടങ്ങി 855 വരെ ബോക്സസ് എടുക്കുക. Now you are having proper subsets. 1, 0, 2, 2 subsets are the proper subsets. അപ്പോൾ ആ subsetsനെല്ലാം ഒരു sum ഉണ്ടാവും. So that sum, so these are your objects. So 1, 0, 2, 2 objects are there that has to be distributed among 855 boxes. So since 1, 0, 2, 2 is greater than 855, so by pigeonhole principle, there will be at least 2 objects in one of the boxes. അതായത് ഒരേ സം വരുന്ന 2 സബ്സെറ്റ്സ് എങ്ങനെയായാലും ഉണ്ടാവും. Okay. So let us write that using pigeonhole principle. So now treat the 1, 0, 2, 2 non-empty proper subsets of X as objects and create 855 boxes for the sums. And since 1, 0, 2, 2 is greater than 855 by pigeonhole principle, so there are 2 distinct non-empty subsets B and C of X such that they have the same sum. So therefore summation over B such that B belongs to the set B, that will be equal to summation over C such that C belongs to C. And ഇനി നമുക്ക് പ്രൂവ് ചെയ്യേണ്ടതാണ് this. ഇനി നമുക്ക് പറഞ്ഞിരിക്കുന്നതാണ് സമ്മ് ഈക്വൽ ആയിട്ടുള്ളത് പോലെ disjoint sets ആണ് നമുക്ക് വേണ്ടത്. So we need to show that there are 2 disjoint subsets such that the sum of the elements are the same. Now ഇനി Bയും Cയും 2 different subsets ആണ്. So B and C are 2 distinct non-empty subsets. So B is not equal to C. So B cannot be contained in C and C cannot be contained in B since they are ഒന്ന് മറ്റൊന്നിന്റെ proper subset അല്ല. So clearly B is not a proper subset of C and C is also not a proper subset of B. അങ്ങനെ ആയി കഴിഞ്ഞാൽ the sum cannot be equal in that case. Now let us take y equal to B minus B intersection C and Z equal to C minus B intersection C. Okay. Now ഇപ്പം നമുക്ക് summation of B such that B belongs to B is equal to summation of C such that C belongs to C. അപ്പോൾ these two sums are equal. ഇനി ഇതിൻ്റെ അകത്ത് സെയിം എലമെന്റ്സ് ഉണ്ടെങ്കിൽ ഞാൻ രണ്ട് സൈഡിലും ആ സെയിം എലമെന്റ്സ് റിമൂവ് ചെയ്ത് കഴിഞ്ഞാലും the sum is going to remain the same. This sum is same, so the same numbers are repeating on both sides, so cancel out the same numbers which are repeating on both sides, so again the sum is going to remain the same. So such set of numbers will be given by B minus B intersection C and C minus C intersection C. So this is our set Y and Z. So therefore we will have summation over Y such that Y belongs to Y will be equal to summation over Z such that Z belongs to Z. So therefore Y, so capital Y and Z are the required subsets. So this is the solution for the problem using P-General principle.